Okay, it's Monday and it's day two of the series circuits, using resistor networks. Okay, and today we'll go through a number of different topics that are quite important. But first, let me just say congratulations to everybody. You all passed. You did well on the midterm. Okay, I sent out the grades, and we'll go over the answers in our Zoom meeting. Then we'll get into what today's lesson is all about. So today we're going to start out with a very important law in electricity, especially in DC electricity, okay, called Kirchoff's voltage law. It's one of his two laws that are very important that talk about, the first one talks about voltage. The second one talks about currents, okay, and how they are divided in a circuit. So because it's a series circuit, we get Kirchoff's voltage law because a series circuit actually does voltage separation. In other words, it does the output from a different resistor in a circuit will give you different voltages, okay? And we'll go through that. We'll figure out how we can actually get a specific voltage out of a resistor network, all right? The Kirchhoff's voltage law simply says that if you have a closed loop system of an electrical circuit, if you go around that closed loop, okay, the sum of the voltage drops are voltages that are used up on resistors. If you sum all those up, they're going to be equal to the voltage that is input, the net voltage that is input to the circuit. So for example, if you have a 12-volt source, then the amount of voltage drops around the circuit will add up to 12. So what you get out is what you put in. So it's really that simple, okay? And because you have these voltage drops and this voltage division, then we get different outputs that we can create. But what can be tricky sometimes is if you have a network that has more than one source. Well, if it has multiple sources, then we take the net effect of all the sources. In other words, if you've got a battery that's plus 12 volts in one direction and a second battery somewhere along inside the same circuit, but it has negative 6 voltage in the opposite direction, okay, then you essentially powered that entire circuit by only 6 volts, okay? So it's a net voltage thing. And finally, we get into the very important topic of grounding. All right? If any of you are working in the area where you have to connect a black box to something, and you'll have to ground that box out. Grounding is a very important thing that we need to do in our circuits because the ground itself sets up a zero potential. It's essentially, there's no energy at zero potential. Basically, you've reduced everything down. The number of positive is equal to the number of negative parts. So it's all even, it's a ground. Now you can go below ground, giving you a minus potential. Minus potential then will have energy go from a negative up to a positive, okay? Or what's more common is we go from a positive to a negative or ground, okay? If you remember, if you have a car You got a battery in there. You remember you've got a red wire hooked up to one terminal of your battery, a positive terminal, okay? And that supplies the energy. And the other terminal is grounded. It's grounded to the chassis of the car. In other words, all the iron in the car is what our ground is. Okay. Now make sure that you understand that even though it's ground, it can carry electricity. All right. It can carry electricity. Okay. Because if energy flows to the ground, okay, it has to keep flowing down to be sunk into the ground. All right. So when we talk about a chassis ground, okay, we're talking about that which holds up the assembly of circuits. All right. In this case, if it's an automobile, for example, then the red wire will energize your radio, will energize your spark plugs, will energize anything that the lights, okay, anything that runs on electricity in your car. And it goes from the positive down to the chassis ground. All right. And it's important to establish that ground. When you create a ground, okay, in the case of a car, for example, you've got a braided copper wire, actually a braided copper strip, okay, that's actually nickel-plated copper, okay, and the interface between when you make the connection, you've got to make sure that that connection, one, holds up to anything that would cause a corrosion, because then that eats away on the metal and you lose your contact. And number two, that it has a very low resistance. It's especially important when you have using electronic components that use very low power. Okay, very low power can be just used up by just the contact resistance on your ground. You can't have that. Okay, so we do things that we do. If you ever done it hooking up a battery, you wire brush the terminals to make sure that your contacts, your high and your low and your grounding, has to be very good, but especially the ground one. The ground one, because everything goes to ground. You want that resistance, that contact resistance, to be less than 1/10 of an ohm. And actually, if it's really critical, there's a military specification that asks that be tested so that you have something like 15 milliohms maximum of contact resistance. That's for safety reasons, all right? For safety reasons. If you operate something electrically in an area where you can have combustibles, okay, you want that grounding to be very low resistance. So the way we treat that, and if we want it to stop the corrosion, we do a number of things. If we're grounding out to aluminum, okay, well, aluminum gets anodized. Anodized means you create an aluminum oxide, okay, that protects against corrosion. Well, if you protect against corrosion like that with an aluminum oxide, all right, that will increase your contact resistance. So when you're grounding to aluminum, you first have to clean that aluminum spot where you're going to ground to, and then you have to protect it with what we call a chemical conversion compound. Okay, so you kind of gives it a kind of a yellowish color. Okay, and gives you just a very faint protectant layer so that it doesn't corrode. Another way to ease down on that is to grease it up a little bit, put some grease around, anything to keep water away, because water is ionic. It will conduct electricity and therefore create a possibility of corrosion. Right? Corrosion is caused by ions. And there's nothing worse. There's hardly anything that's worse than salt water. All right? In fact, there's a test that we do, the military asks us to do. It's called a salt fog test to make sure something doesn't corrode. All right. So I'll go over a number of examples, and also I want to give you a little bit more on grounding, which I'll do at our Zoom meeting. Okay, so, but congratulations to everybody. Everybody passed. So let's get on, and tomorrow we will start the parallel circuits.